Does the audio sound fine? Does the audio sound fine? Cool. Hello, Chase.
Sorry. All right, so guys, we're going to start now. This is Andy Riedlinger's second. I don't know if we've really decided if we're going to third or if this might be the end last one for this semester. But, okay, regardless, it's been a successful thing. This is my first time doing an honors conference, but I think it's been a nice opportunity to show students things that they wouldn't normally get to see in class. And what Andy's going to talk about today is a up and coming game engine called Godot, which I first became aware of about not even that long, 2-3 years ago. You know how long it's when it started? But anyway, it's a open source free engine, and a lot of people I don't think are aware outside of maybe this department that when you use a commercial game engine like Unity or Unreal, if you do this professionally, both of those companies are going to take some money out of your pocket. And the nice thing about Godot is it's completely free, so anything that you make, you own, and you don't owe anybody anything. And the guy that manages or that kind of heads it up seems to be a big open source proponent that he actively does not want this ever to become a commercial game engine. So every time that I download it and try a project in it, which is usually about a year apart, I'm continually impressed of how easy the engine is to use, how organized it is. It's just I think going to become a real big player in the gaming industry. So with that, I'm going to mute myself and turn it over to Andy and let him go.
Okay, hello everyone. First off, if the audio is bad or anything, just tell me. If you ever have any questions, type something in chat. I should notice, I'm going to turn my audio up so I can get the little ping notification. Yeah, so this is over Godot. It's a free game engine, and some of the just sort of main things about it is, like Jason said, is it's completely free, open source. The actual license on it is the MIT license, which basically means you can do whatever you want as long as you include the MIT license in there. Just say, hey, MIT was involved with this. This is a 2D and 3D engine. You can do a lot with it. You can even do VR with it, I saw. I didn't experiment with that, but it's an option. And one of the things about it is the current 3D rendering is a bit limited. If you want a really large, realistic game, you really need to use Unreal being the biggest competitor for that, or Unity, which is still great for 3D. This Godot isn't quite up there in terms of 3D yet, but it's still great for small games that you want to have like a cartoonish look, and it can still render some stuff pretty well as long as there's not a ton of it. And it can also export to a lot of devices, so you can put it on Android phones, iOS, make web applications with it, put it on Mac, Linux, Windows, or Windows Universal, which is sort of an API for also making some things common between Xbox, Windows, all the Microsoft platforms. And it has 4 languages that it officially supports. There's GDScript, which is a lot like Python. That's the one we'll be using today. There's VisualScript, which looks quite a bit like Unreal's blueprint system in it. It's pretty nice, and there's actually some things I like more about it, honestly. I might show it off if there's time. You can also do C#, which is sort of in the in-between. If you want to do stuff in a language more similar to Unity, go ahead and use it. And there's C++ as well. And the Godot engine uses sort of a node-based organization system, which we'll get a bit more into in a second. So for installing it, it's just really simple. Google Godot engine, go to the download, select your operating system, and you just download it. It gives you a zip file, you unzip it, and it just gives you a single executable. It's like maybe 40 megabytes. It's extremely small and very quick to install. So some of the first looks at it is, I'm actually going to open up a project over here. So when you open it up, it's going to have the command prompt in the background. You can just ignore that for the most part. and you can select a new project. I'm going to put this in my E drive, your E drive. And so the window is pretty similar to some other game engines where you have your main view here in the center, you have your files down here in the left. You can move this stuff around if you click the dots and change the dot position. Then you also have your sort of scene explorer over here, which is where your nodes will show up, and inspector for whatever you have selected. And up here at the top, you can switch between 2D, 3D, looking at the asset library in your scripts. But for now, the main thing just to notice is big scene view. So we're moving around in the scene view. It works a lot like most applications you probably work with, where you can use the middle mouse or right click to pan. And then you can also interact with anything that's in there. You can use the scroll wheel to zoom in and out. And then real quick, I'll just add in a node in here. So you can just sort of drag them around freely. And up here is a toolbar for changing how things work. I drag this sprite in. You can switch between these modes by using W to do translate, E to rotate, and R to scale. Actually, that's a ruler. S to scale. Oh. So going back to how it's node-based, a game is built up by making a tree of nodes. A tree of nodes is saved as a file called a scene. So a scene is just a collection of nodes. And if you're coming from Unity, or this might seem a bit confusing at first because a scene seems like just a file that you load up and it's more like a level. In here, a scene, if you're used to Unity, could be treated as like a prefab from Unity. And each node has its own behavior. They're sort of like Unreal components. Like over here, this player node, which is actually a cinematic body 2D, allows for movement. And then you have an animated sprite node, which is just for your display, and a collision node for your collision. So each node is more like a component from Unreal, and they each have their own behaviors, they each do their own thing. There's quite a few of them that will automatically do stuff for you. So there's like a camera node, there's a timer. We'll get more into what specific nodes there are later. And each scene has one root node, which in this case would be this one called player at the top. And this node should reflect whatever you are making. So some 2D node types are the sprite. Back over here, you can press this button up here to add nodes. You can search for what you want. So if you want a sprite, and you can set the texture over here. We're going to load it from this icon, or you could have just dragged your picture into here as well. Quite a bit faster. But that's a sprite node. It's just a visual in here. You can see over here in the inspector all the information about it. So a transform is a position. You can change this around to change where it is. And just other things in general. Other nodes are an animated sprite, which is just a sprite, except it also has animation on it. Paths, which allow you to sort of draw out paths. Think of it as if you had monsters in your game that you want to follow a set path. It's really easy to do that in Godot. You can just sort of draw it and they'll follow it. The generic position, or if you just want to, maybe you have a spawn point, you might use a position node for that spawn point. And then a timer, which is primarily used for triggering events using things called signals. We'll get into that later. And these are probably the most important 2D nodes. They're more based around the physics. So first there's the kinematic body 2D node. And before I get into what these are, all the physics nodes use Godot's physics system. However, they respond to it differently. So kinematic node will allow you to fully program your movement without your movement really being affected by the physics except for walls. So you're not going to be able to move through walls and stuff. It's not going to be automatically applying gravity and all these forces to you. All of that's up to you. It's just going to keep you from doing stuff, basically. rigid body is the opposite of that. It's fully integrated with the physics. If you have a bunch of rigid body nodes hitting each other, they're going to be bouncing around off of each other, obeying gravity, doing anything. And then a static body is more like a wall. It's something that stays stationary, but it's going to block you from moving past it. And then we also have an area 2D. An area 2D is able to detect when things overlap it. If you're familiar with Unity, it's like a trigger. And there's also the collision shape, which defines a collider in your object. Now, unlike some other engines where you define a collider and you say, like, this will block stuff or not, you put a collision shape onto one of these nodes here. And depending which one it's on, they'll do things. So if it's on any of these physics nodes, it'll block anything that hits it and obey the physics there. If it's on an area 2D, it's going to just define where that overlap position is. So to sort of show that over here, we keep this here. Go ahead and add a static body. You'll notice this little exclamation point indicating that there isn't a collision shape on here. And to add one, you just click it, go to collision shape V. And then over here, you define the shape by clicking the shape section, choosing what you want. I'll make this a rectangle. And then you can sort of zoom in and make it fit your shape. So now this is a kinematic body that has a shape. If the shape ever touches other physics objects, it'll collide with them. If this was an area 2D, instead of colliding with them, it would pass through it, but it would notice that it overlaps stuff. Then there's also like an audio stream player for doing audio non-positionally and a bunch of other stuff. So onto the root nodes, let me just get rid of everything here. So you'll notice at first that it wants you to create a root node, and it has these options for you. So these all by default do certain things. So like the 2D scene node, this automatically creates a node 2D for you. 3D makes a spatial one, and user interface makes a control one. Now, even though these are here, they're normally not that useful to actually use. Typically, you want your root node to define what your object really is doing. So like if you have a character who moves around, instead of using a node 2D, you probably use a kinematic body because your player is defined by its movement. But you could always just use a node 2D, put on a kinematic body here. It won't really change anything besides your structure. But just know that typically these probably aren't what you actually want to use if you want to be really organized. And then for the user interface one, you really want to use a canvas layer most of the time instead of a control. And we'll get into that once I cover the user interface. So going on to the scripting language for this, like I said, it's a lot like Python. There's a few differences. One being that when you're declaring variables, you have to use the word var before it. And then another thing you can do is you're able to specify types in here as well. I won't really be doing that here just because I imagine most people will be used to not defining their types, but it can be useful. And in order to do that, you just put a colon after the name and the type. So here the variable C is a string, and we're also assigning to it. And a shortcut to doing that is doing a colon equals, which it'll infer the type on the right. And then for functions, instead of using def, you're going to use func. You also can't have named parameters really like in Python. In Python, you could specify the name of the parameter and the value of it when you're calling it, but you can't do that in a GD script. And then just some name changes. None is null, false is lowercase false, and true is lowercase true. And then some other keywords and shortcuts. So there's the class name. First of all, every script in Godot by default is a class. It may not look like a class because it doesn't have the class definition there, but that's how it's treated. And you also extend a type at the top of it. And that type is normally the node that it's attached to. So for example, I'm just going to start making what will eventually be a player node. So if we have a kinematic body 2D, first of all, you can have one node per script, or one script per node. To do that, you just click this button right here to add a node to, or add a script to a node. I'm going to change the file location for this. Okay. And that will open up in here. So all your script editing is actually done in the editor, which is actually pretty convenient. And you'll notice up here it automatically extends the kinematic body 2D, which is this. So this gives it access to everything a kinematic body can do, as well as anything you do with it will directly affect this node. So for example, if you were to use, there's one built-in called move and slide, and you get a velocity vector. So using this will actually move this node to the right or the left. Once we have visuals on it, you'll actually be able to see it. And then another useful thing is exporting. Exporting is, if you're familiar with Unity or Unreal, is making something public so that it can be in the inspector. First, over here, these are all the options. If you were to go into the script for your player, and let's say we do export var speed, and set this to 400 for now, or 300. Go back to the player node. You can see that you can now change it over here if you wanted. So this is really useful for seeing how the variables change or setting them at runtime. And you can also specify a type that is there. So for example, over here we have export packed scene. So here nothing by default is getting assigned to it. This has to be assigned in the inspector. The packed scene is just a scene type. And then next up is for getting stuff when you load in. So there's this function here called _ready, and notice that all the functions that are sort of built in that are automatically going to get called begin with an underscore. So if you do func underscore, these are all your options. So for trees entered, exited, for when you're drawing. But for sometimes you want to get access to a node, do something with it. So let's just add on to here for a second. Animated sprite. Maybe in our script mode, we want to do something with our animated sprite. So to do that, you want to call get node, and then you can just put in the name of your node. And this will get a reference to it. A shortcut for this is the exact same thing. Just putting a $sign and then the name. You'll see this very often in documentation. It's really commonly used. If we want to assign a variable to this, like so, there's a shortcut to doing this where it's important that the node is already loaded into the scene before you access it. So that's why it has to be in this _ready function. But if you use the onReady keyword before, you can actually assign this outside of here. And it won't complain. Without this, it's gonna throw an error, being confused, complaining that onReady isn't used. Next up is there's signals. Signals are sort of like events. We'll get into those more later. I'm just bringing them up now, as well as yields for coroutines. Also farther down. So some of the basic scripting that you'll frequently see, like I showed, there's the get node where you just put in the node name. it retrieves a child from the tree, and it retrieves only a direct child of whatever node it's on. If you want to go farther, you're going to have to put in the full path to it by putting slashes in between the additional children. And then there's also the shortcut I showed as well. For getting random information, you can use the randy or randy range functions. Now, an important thing about using these is the seed is going to be the same each time it's ran, meaning the random numbers are going to be the same every time you run it. In order to ensure that doesn't happen, you want to call randomize somewhere in your script. So this will probably be put on your root node, for example, and just on load you'll call it. Then some other things is queue free and you pass over. This will delete that node and all its children. So if you want to remove something from the scene, go ahead and use this. And if you ever want to change your scene, you can call get tree followed by change scene, and then pass in the full path to scene. And by path to the scene, I mean like down here. You need the path to this. Now something really convenient here is, let's say you need the path. Instead of reading this and manually putting it in, you can just sort of drag and drop it into the script, and it'll put it there for you. And also, just a side note, this RES here stands for resources. So this is just your resources folder, and everything is relative to it. Okay. Yeah. I find Randy to be nicer most of the time as well, Chase. And then, so we're going to get a character up here and running real quick. So first things first is we need input. And in order to access input, you have to set it up specifically, sort of like in Unreal. In Unity, you can get around it, but Unreal is going to, for the most part, force you to create them as well. To do that, you just go to the project settings, the input map, and then add an action, hit the plus. We'll go through this here in a second. And then for using the input in the script, you just call input dot and then is action pressed, name of the action, and you can use for just pressed for if the key was just pressed down, and just release if it was just let go. So just set these up real quick. Project settings, input map up at the top. Here's where we put in our action name, so I'm going to make it move left, move right, and a jump. And then down here, where they are, just hit the plus sign, select the key option, and you just press whatever key you want to be assigned to that. So I'll go with A. I'm also going to assign the left arrow key as well. Do the same for the right. And for jump as well. Okay. So once those are set up, you can access input pretty easily. So to do so, you can just do input dot what it again is action pressed, and we'll go with move left. Oh, that's not what I wanted. And before I finish setting this up, I'm going to add some more variables up here for our character. So our character is going to need a speed for moving left and right. We're also going to need a jump power. And we're going to set that equal to 500. We're also going to want a gravity and make that 1300. We'll also store health here for now as well. Okay. So we also need a velocity. And we'll just make that a vector that currently isn't moving. So a vector here is just an x and y component. You can access the x component by doing vel.x, y component by doing y. And To set our speeds, we're going to, in our input, first of all, each frame, we don't want to be adding to our speed, so we're just going to set it, the x velocity back to 0 for a second. And then if the left is pressed, we'll subtract the speed. And right is pressed. We'll add the speed to it. That way, if you hold left and right at the same time, you're not moving. And we'll also leave it just that for now. And then in order to move, it's really simple. You just do move and slide. And we're going to pass it the velocity. We're also going to specify which direction is up. There's a default for up built into the vector. Now, something a bit odd that you'll notice about this engine that's common in graphics is that the top left right here is 0, 0. So up is actually the negative direction. So the up vector is 0, negative 1. Okay. And then with that set up, we need to be able to actually see our player. So I'm going to import some things into here real quick so that we have some assets. To do that, you can either just drag them into the file system, or what I'm going to do is actually open the file manager and drag them directly into here. Some things set up from before. Okay, good. Back in here, it'll import all the assets that just got dragged into there. Hopefully everything's fine. There we go. So next, going to go into, this is just some assets I found online. I have a text referencing where I got them from, so you can get them as well if you want. They're off of itch.io. And we're going to go with a ninja frog, because who doesn't like a ninja frog? Okay. So in order to set up an animated sprite, we're actually going to set up the animation as well here. Pretty simple. Over here, where it says frames, go ahead and click there and select new sprite frames, and then click that. And that'll open up your animation editor. So right here, I'm just going to make a few animations and add by clicking here, double click to change the name. And right now, I'll only set up one of these, which will be the idle. And the idle is stored in a sprite sheet. So to do a sprite sheet, you click up here to add from a sprite sheet. Browse to where it is. You want the idle one. And then up here where it says select frames, you want to make this, so this isn't the pixel count of the sprite sheet. This is actually just going to slice it proportionally to how many sprites there are. So vertically, we only have one column or one row. And horizontally, there's 3, 4, 5, 11 of these. You'll see it puts lines in between each of them. You can go ahead and select them and add, and I'll put them all in here. Over here, with our animated sprite, we can select idle animation so we can see that. There's our little frog guy. And you can also set it to playing to see what it looks like. Now these are supposed to run at 20 FPS, so we can change that down here. That's an idle animation. And that's all you really do for all your animations. You just import from a sprite sheet, set the count, and you set the speed, and you're done. It's really simple for 2D. And then lastly, first of all, this is a bit small, so I'm going to make him a bit bigger. Go. And also, this is still complaining about there being no collision box, so go ahead and add one of those. A lot of people will use capsules for a player character. In this case, I'm using a rectangle just because I personally don't like capsules in platformers that often, because capsules will sort of get caught on the edges of or corners of squares if they're in there and ramp up them, which I don't want. Okay, so there's our guy. He has one animation, which is idle, and he has a collision box. And I'm going to go ahead and save this scene. And then I also have one scene that I already have set up. So I set this up using a tile map. If there's time, I'll get into that, but there probably won't be. For now, just know these are all different tiles and they all have collision. So in order to add something to a scene, we want our player to be in here. You go to up here. Instead of the plus, you click this little link button, and then you select the scene that you use to make your player. And there he is. You can drag him around from where you want. Put him right there. And now you should be able to go to up here to the play button, hit play. If there's to be a main scene selected so it knows which one to play, we'll go ahead and select that and just have it be this root one. And I think I have, yeah, get rid of that. So we have to call this function because this isn't one of the ones that gets automatically called. So we're going to use the physics process, which runs every physics frame. So this runs 60 times per second default. And we're going to call our get input and also move this out to here. Now if we run it, you'll see that the left and right arrow keys can move them right. Now, there's still not a lot going on here. So can't jump, there's no gravity, but notice that can't go through blocks or anything. That's one of the things that I really like about Godot, is that if you use a kinematic body, you can script the movement all you want, but it'll still obey collision like this. If you've ever used Unity, for example, if you put a rigid body on something and set it kinematic, as soon as you move through a wall, you're just sort of going to move through the wall. Instead, you have to manually disable whatever parts of the physics engine you don't want. So this is, in my opinion, is quite a bit nicer. Okay, next is for adding the jumping. So first of all, we need to be able to fall. So we're going to add our gravity in here. We're just going to multiply gravity times delta. So delta is the time since the last frame, which means gravity times delta will change the velocity of y by gravity after 1 second. So the velocity of y will go up by 1300 every second. Okay, and we're also going to save the velocity into here, because move inside will also change your velocity a bit. Based off, if you're hitting something, it might decrease your movement speed because you just, if you fall from really high up, you're probably not going to hit the ground full speed, as well as a few other things. And with that, you can see that now he's actually properly on the ground. To jump, you just need to change the y velocity to be negative, technically. So we're going to check to see if the jump key was pressed. And we're also going to check to see if we are on the floor. So on the floor is also part of the kinematic body. It'll automatically know you're on the floor if you're touching another collider, and the angle between you and it is a certain degree. A lot of engines you have to manually make this for yourself, so it's really convenient with Godot where it's sort of already there. So if we're on the floor and we press the jump button, we're going to set our velocity to the negative jump speed because upwards is in the negative direction. There we go. I can jump around. Gravity is making him fall back down. He won't fall through the blocks because of the collision. And you can't jump when you're already in the air because of the on floor. Okay, so a second here. Next up, we're just going to finish setting up this character. We're going to add the animation for him as well. So we'll have, first of all, depending on which way we're running, we're going to want to look in a certain direction. So if our velocity in the x direction is 0, we want to swim around. Now, in order to do that, we need access to this animated sprite. And to do that, I'm going to save it into a variable up here. And we have to use onReady and animated sprite. So this is calling get node animated sprite. Oh, I apparently already had that up here. And it'll do that at the start. Now, a lot of the tutorials, you'll see this used everywhere. And there's nothing wrong with that, really. It will run slower, not much slower, especially if you're just making a small game. This is technically a bit more efficient if you cache it like this, but either way is fine. I just like to store it if I know I'm going to frequently be calling it. So here, if the velocity for the x direction is less than 0, we're going to call flip h, and we're going to set it to true. If the velocity is greater than 0, we want it to not flip. And I have to call that. Now we'll look in the proper direction. Now we don't even have the animation playing here. If we want the animation playing, you could have left the check mark on playing here, but I just don't like seeing it always playing while looking in the inspector. So just set that up. We're going to, in the ready, set it to play. And then see he'll do his little idle dance. I'll quickly set up the other animations here. So for running, I'm going to add in the run. This is 1, 12. Is it back? Everything good? Okay, good. Okay, so with the animation set up like that, I just did the same thing for all of these. You still need to be able to transition between them, as you do in the script. So we'll say that if the absolute value of the velocity in the x direction is greater than 0, m.animation, we're going to set it to run, which just matches the name of the animation over here. We'll do if the velocity for the y direction is greater than 0, the animation is jump. Actually, this is less than 0. If it's greater than 0, that means we're falling. So the animation should be fall. If, we'll just put an else here for idle. Don't want more than one animation playing at a time, so make these else-ifs. And there we go. Oh yeah. So the velocity for the y is constantly getting smaller because of the gravity getting set beforehand. This actually needs to be set afterwards. In a constant falling state. There we go. Little guy runs around, does his jump animation, falling. We're so happy. Okay. So I'm going to skip around here in the presentation a bit. We're going to go to signals. So signals are events that are triggered, and you can see them over here. So if you select a object like the player, you go to the node tab and signals, there's all these events that can happen. So this will happen when the mouse enters the collision box over here, when it leaves, all sorts of things. And you can hook these up to call things when certain events occur, such as, go ahead and go with the mouse entered. And you just tell it what you want it to connect to. So we're connecting it to the player script. It'll automatically put it in here. And then I have to print something. Maybe that one doesn't do what I think it does. Let's go with a more specific one. So the example I want to use is a timer. So the timer has a timeout signal. And this gets called when the timer is done. Let's set this timer to wait 1 second, and then it'll go on forever, and it'll auto start, and we'll connect its signal to the player. And here we'll just add some stuff. Let's make a variable, set it equal to 0. We'll print I, and also add 1 to it. Now you can see over here in the output, it's a bit small, but every second this is going up by 1. That's what the signals are for. They're just callbacks that happen when something occurs, and they're really useful for making sure that your nodes are decoupled from each other and not constantly relying on references to each other. So that was the GUI method I showed you to use them. If you want to do it through code, you can. It's just right here. But you don't really see that often. It's normally nicer to just go to the GUI. Now, if you want to make a custom signal, you can do so by just using the signal word and giving it a name. So I'm going to say on hit. So like when this checker is hit, for example. And get rid of this. Make a function that's called when we're hit. And when that happens, you want to emit a signal, and it'll be our on hit signal. So whenever this code is run, this signal happens. You can now see that there's an on hit one here, and you can hook that up wherever you want. Now what that's more useful for part is when we get into coroutines for a second. So coroutines, the way they work is a bit complicated. I'm not going to go into them too much. You know they're there when they have this yield word inside of a function. What it essentially does is when a function gets called, it reaches the yield word, and then the function pauses. And then when it gets told to resume, it'll continue from where that yield was. There's a few other things that you can do with them as well, but that's the main gist of it. The most useful syntax for them is with signals. And what you can do is you can call a yield, pass in a node that's causing a signal, and then a signal name. And what this will do is it'll pause once it gets there, and it will continue after that signal gets called. A useful example of this is using a timer. If you want something to happen after 5 seconds, you can do yield get tree create timer 5. So this creates a timer that ends after 5 seconds, and you attach to its timeout signal. This way, just make an example real quick. We'll just call this on startup. I don't know why that's blue. I hope that's not a keyword. So you see it prints hello, and 5 seconds later, it prints out world. Now, another useful example for this is you can do it with an animation, and that's what I'm getting at. Is you attach it to the animation finish signal so that once an animation is played and finished, you can start over. So the reason this is important is for, say, a double jump. So we want to be able to jump a time, but we don't want it to run multiple times. We don't want it to infinitely run. We want it to run only once and then transition back to the jumping animation. So in order to do that, first we need to set up the double jump. So to do that, I'm just going to make a variable. And we're going to change this input here a bit. And we want that to be, if we haven't double jumped yet, we can also. And here we set our double jump to true. We also need that to get set back false somewhere, so we'll do that in the physics process. And I need the animation step here. So we could put an if statement in here, but then we'd have to check for a lot of things like, is the animation done? When can we transition back to doing these animations? That's a lot of work. So instead, we sort of just want to be able to run one animation and pause all of this. So first, I'm going to make a variable for pausing animation. And we'll, in our animations down here, we want to be able to still change direction if we're doing a double jump, so we'll put this afterwards. The animation is paused, we're just going to stop. We're not going to do the stuff afterwards. So now we need a way of switching to the animation and knowing when we're done. So we're going to make a useful play animation only once function. And it's going to take the animation name. What it's going to do, it's going to do anim.animation equals that. We're also going to then yield. Well, first we need to tell the other animation to pause. Going to yield on the animator. We're going to wait for animation finished. Then afterwards, we'll unpause the animation. Everything should be good. And also over here in the double jump animation, we don't want it to loop, so we're going to uncheck that. So now, that needs to get called. When we double jump, we're also going to do play animation 1. We're going to do double jump. That's what I call it. Yep. There's, well, let me back to 20 FPS. There we go. It does his double jump, he transitions back to his falling, and everything's good. So that's a really useful example of using the signals as well as coroutines to change your animations. The main thing to take away is really the signals. These are really useful. So let's say you have an enemy that hurts you, and you want your health to change in your UI whenever you get hurt. Instead of your character having a reference to your UI and then saying, hey, change the value here to 80 because my health got reduced. You can set up a signal, and when you get hit, you call emit signal, I was hit, and you set your signal up that it calls a function on your UI. That way, there's no direct in the code reference to the UI. You're just emitting the signal, and the UI is listening to it. You could get rid of one, and the other wouldn't break. So the other thing is we can make a UI real quick. So I'm going to make a new scene here. And instead of using user interface, I'm going to create a canvas layer. So a canvas layer, what it does is it affects the ordering of sprites in the scene. So everything on one canvas layer is on a certain layer, and anything on the other is somewhere else. So the reason a canvas layer is important is because if you just use a control and put UI elements on it, you could have some of your UI elements hidden behind things, some of them not, which is confusing. By using a canvas layer instead, you're guaranteeing all your UIs on the same layer. If you can see any of your UI, you can see all of it. That's why you use this instead of a control. And then any UI nodes are just underneath this control tab. For the most part, a lot of them are pretty self-explanatory. You have labels, you have a color picker, you have a pop-up, you have panels. For now, we're just going to use a label. And in the inspector, first I'm going to change the font because the font is sort of bad that they provide. So to do that, you go to custom fonts, dynamic, and you select the font. I use Comic Sans because any chance I get to use Comic Sans, I'm going to use Comic Sans. And we'll also make it a bit larger. I'll just say like help. And then also add another label. This one will actually be for displaying the health. And I also want the font setting. So instead of redoing all this setup, I'm just going to click here, click copy, go to the health display, go to its custom font, and paste the values in. Default value is 0. Now notice that while you're in here, you can move them around freely, but you can also use this layout button that appears at the top. So if you click this, you can anchor it to spots. So like bottom left, center. And this is important so that your UI scales properly. I'm just going to do it to the top left. I'm also going to set its margins. So we're going to go with 40, 40. The health display, we'll go with 40 and 150. Default, will have this be 100. And we're also going to add a script here. And we're just going to have this have one function really, and we're going to have it be func update health new value. We're just going to get the health display and set the text equal to a string of the new value. We're also going to go to the root here and add it into our scene. So once again, up here, select canvas, you can see health is in there as well. If you were to use buttons and stuff, you do the exact same things. The only difference is buttons are interactable, and the way you work with that is just the signals. So just as a quick example, whenever this button is pressed, it would just call these signals. So you would double click button down, choose the script that you want to do stuff with. It'd probably be on the canvas layer. And then any code we write here will trigger when the button gets clicked. So I want, whenever this player here takes damage, to update the UI. And to do that, we have our health. There's a signal for when we're on hit, and you can also specify these like values. So you can pass to a signal any person you want. And this is going to be the new health value. So to do that, you just do the emit signal, and then afterwards you put the new value. So we'll do health. Then back in our root, you can select the player, select on hit, tell the canvas layer about this, and what was the name of that function real quick? We want to link it to that one. Update health. There we go. You can see the little green icon here to say that a signal is hooked up to this. So this will get called whenever that signal gets emitted from the player. And just real quick to make that happen, I'm just going to make it happen every few seconds. So we'll use this timer that happens every second. And we'll say hit. So every second we're going to get hit. That'll cause it to lose health, emit the signal, and the canvas should recognize the signal and update the health value. And there you go. You can see every second it's going down by 20. So typically you'd want your hit to be set up by an enemy running into you and causing a hit detection. I just did it this way now because we're running out of time and I want to get through semi-quickly. So the other things that I want to show off, to save you my typing, I'm just going to pull up the completed project of this real quick. Actually, I have it open on the other screen. Okay, so just real quick to show what's in this one. You'll have the character, you can still move around, jump around. There's also this pig guy. Whenever he hits you, hit animation plays and you can see the health changes. Don't have anything actually happen when the health reaches 0, but it's there. And then I didn't show these off before, but these would have worked in the previous project too. These are platforms you can jump up through but not down. They're actually really easy to make. It's just a collider, except in the collision section, you can select one-way collision. If one-way collision is turned on, you can't fall through it, but you can go up through it. So also very useful for platformers. Okay, so the way the rest of this set up here is, first of all, you'll notice in this one the camera follows the player. To do that, you just go to player, put the camera on him from here, and you just have to check one option, which is to set the camera to be the current camera. If you don't set it to be the current camera, then it's just a static view, but if it is, the camera will move around with him, and that's what you'll be seeing out of. As for this pig here, he uses a area 2D instead of a kinematic body 2D. He actually isn't really colliding with anything. He only detects overlaps. But other than this being an area 2D, for the most part, it looks the same. The main difference you'll notice is in the script for movement. Instead of like setting velocity and using move and slide, you just directly set the position. But the way this pig is moving is actually using a path. And these were one of the last things I wanted to show off. Is you can make this path 2D here, and just as an example, I'll add another one. With a path selected, you have these new options up here for adding points, selecting points, removing points, closing points. But if you choose the select option, you sort of click, it adds a point there. Click somewhere else, adds another point, click, click, click. Make as many points as you want. If you want to close it, you can close the curve, or connect it. But the cool thing about these is after you have a path, you can put as a child to it a path follow 2D. And what this does is there's now this offset value. And you'll see as I move this offset value, it changes the position of the path follow 2D on the path. And this also loops around. So what you can do is here is actually a path that has a point here, a point on the left, and then another point on the right. So if you look at this follow, you'll see as I drag this up, it goes to the left. Halfway through, it starts going back to the right, and then it'll loop and do that again. So this pig here is exporting a node path, which means up here you can assign a path to it, or a node to it in general. This could actually be any node, it could be a collision node, but in this case we want it to be a path. So if we select this, you can just sort of select what goes in there. These aren't at all what I want in there. So back in the root, you can see that the enemy has set in there the path follow 2D. And by using that, the enemy can get a reference by calling get node with that path. I wish there was a way to just get the node path directly without having to call get node and having them put in the path, but this is just the way you have to do it. And then inside of here, instead of updating the velocity, you have a current offset value as well as a previous position for animation. And every time this runs, I just add to the current offset by the speed and multiplied by the time delta. And then you set the position of the path follower by setting its offset, like we did when we were dragging it in the inspector. Then we just set the position of the pig to the point on the path that we're currently at. So that's a really easy way to make pathing enemies. You could also do it by using an animation as well. I sort of like this way more. And then this is just for figuring out what direction you're moving. If you're moving in the other direction, flip your character so you're facing the right direction. And finally down here is the important thing for character hit detection. If you'll notice, an area 2D in the signals has a area entered and a body entered. We want a body to enter because it's using a physics body instead of another area. The character is a kinematic body 2D, not a kinematic area. So I have it set up So when a body enters it, it calls this right here. We get the body, we check if it's in a group, which is done in the player next to the signals or the groups section. You can just add a group here. The group is the same thing as a tag from Unity, essentially. So when we get this character and we check the groups, it'll have the player group assigned to it. So if the thing we enter has the player group, we're going to go ahead and call player.hit on it. And then from there, everything in the previous project just carries over. What be hard to do? Oh, follow a, okay, yeah, that should be easy. So if we want the pig to follow that path instead, it'll be interesting which way he faces. I think it'll right. So with the pig and the inspector, instead of this path, we're going to select this one. Run. Now our pig is dancing through the sky. So that's the power of using a path. So let's see what else is. Did I close that? I think that's everything that I wanted to cover. It was a lot, and I know I went through it pretty fastly. There's a video available, so if I went through things too quickly, can back. Yeah, the UI is just a canvas layer, putting any controls you want on it, and then using the signals. Yes. One other thing to mention about the group is they do have two really cool functions that they can use. They have one called call group, which you pass in a group name and then the method name. And it'll just call this method as long as the object has it on everything that's in the group. As well as you can just do a get nodes in group to get every single node that's in a group if you want. Yeah, other than that, there's a lot more you can do. I can quickly show how to export. To export, you just go to, first you have to go to editor and go to manage export templates. There'll be a download button here for the first time you run this. Once it's downloaded, you don't need to do this again. You just go to project, export, click add up here, choose your environment, Windows. Then you can just export the project. There's a bunch of settings over here if you want to look into what they do. The important thing here is export project here will give you exe. This one right here will not. This is more for like if you want to put the project on a different computer and open it in Godot. Yeah, that's all I have. There's a lot more you can do. The documentation is extremely good for Godot. So if it's something you want to do, I'm sure you can do it. So yeah, if you have any questions, I'd be happy to answer. Yeah, so to download Godot, just Google Godot, download. It'll come up here. It's on Mac, Linux, Windows, whichever one you want. Just go ahead and click it. And then you're going to want the standard version unless you want to work with C#. And just get the version that matches your computer, probably 64-bit. And then that downloads and it just becomes a zip folder. It has this executable in it, and that's it. You just run the executable and you're done. So it's really easy to get set up. Anything else?
Anybody else?
No one else is chiming in so far. Jason's computer died.
We just say this over Andy's mic. Can I get a quick virtual round of applause for Andy? All the work that he put into this. The two people in person.
I'm really curious what it would sound like if just a raised hand button is by everyone repeatedly.
And next Monday, I'll put together the bonus project for 1801 if anybody's interested.
Oh, and also real quick, I posted it once, but I'll post it again. Shared folder on Google Drive, anyone can view it. It has the PowerPoint from this presentation as well as my previous one about Unity Editor, and I will be uploading this project right here to that Google Drive as well afterwards. So if you want to view it, you can do that, look through it. And also once the video, which is being recorded on Blackboard, is done, I think Jason said he would post it to YouTube, and I'll include a link on the Google Drive.
All right. Thank you, everybody.
Thank you.
It's,